Okay. Okay, 4-2 looks like this. Okay, it starts out with not unit circles, just two circles. In these circles, you have all the degrees and you have the radians on the bottom one, I believe. So if you need to look and reference back to this, here they are. Okay, everybody good?
Yes.
I'm not talking about these circles. This is what they look like, and there's where the degrees and the radians fall. Okay, first one is right here. All right, this slide. This is 4-2. Yep, I'm going backwards. I did 4-3 last week. Now I'm going back to 4-2. All right, here are the goals today. Let's be able to do this when we're all done. What's tangent of pi? What's sine of 7 pi over 6? And what's cosecant of 120? These are today's goals, and I want you to give me the exact value. And all I want you to tell me is this. When I say give me exact value, I'm really saying what? What? No decimals. So here's the deal. No decimals. But I want you to use your mind. You know what? No calculator. No help. Okay? That's what I mean. We'll come back to this slide later. This is what we're going to do in about 7 slides. And it's actually, I think it's right back on one of your future slides. Okay? All right, so here's your first problem. Okay, you're looking at this circle. And what I did is I took one angle. I called this my initial side. I called this what's the other side of the angle? Terminal. This is the terminal side. All right, now on this angle, I have a point. That point is right there on the circle. Okay. That point is right on the circle. Okay, so now if you're looking at that point and then look at the circle, you see a right triangle right here. Okay. You got the x-axis, and then you got straight up. There's your right angle. Now, this is known as your what? From center to the edge of your circle? R. R for radius. Okay, good. What about this distance from here to here? What about this distance from here to here? Okay, wait. Maybe I didn't say it. On the circle, somewhere, this angle hits the circle, and this is a point. This point is x, comma, what? Y. Maybe you couldn't see that on your notes. Now, let me ask you again. What are the legs of your triangle? What is it? X, Y. Which one's X? Horizontal? Yes. Horizontal's X. Because if this point is x comma y, then this has to be x over and y up, correct? Now this triangle, we're going to use it to come up with some new thoughts on sine, cosine, tangents, okay? So could you answer these questions? Sine of theta, cosine of theta, tangent of theta. Where's theta? Theta's right here, where it's always been. Try it. I know I covered that up with a box. Just write it out. I just want what over what. Yep. Perfect. Okay. Sine of theta is, well, I know you know the words. It's what over what? Okay, opposite over hypotenuse. But Aomi, just using my letters, it's what?
Y over R.
It's y over r. Look, right there. Opposite over hypotenuse is y over r. She's got it. Good? Right here, opposite over hypotenuse. Okay? Silver, cosine of theta.
X over R.
X over r. He's got it. Good job. Aaron, what's tangent?
Y over X.
Y over x. You okay with that? Okay. Now, just really quick, will you do the reciprocal functions? And the reciprocal functions are cosecant, secant, and cotangent. Sorry, it's too much. So what took you the longest was what? Just write it out, wasn't it? Because really all you had to do is do what? Yeah. Just give me the reciprocal ratio. If this is y over r, then cosecant r over y, right? Okay, so that should have been pretty easy for you. Okay, so now what I need you to know, this. This is where we're going today. So we're going to have a triangle, and we're going to use x for one leg, y for another leg, and the radius is going to be your hypotenuse, okay? All right, next slide. Now we get into something called the unit circle. Now, the only thing I want you to know about the unit circle is this. The radius of a unit circle will always be what? Yeah, if you remember from last year, we said the unit circle has a radius of 1. So right there to there is 1, okay? And then here's that point again, x comma y. Okay, so this leg is how far? X. This leg is how far?
Y.
Y, good. Okay. Now, knowing that the unit circle has a radius of 1, answer these questions again. What is sine of theta, cosine of theta, tangent of theta? Get it close to the same thing. Sine of theta. Lauren, what do you think? She says y over 1, which is opposite over hypotenuse, y over 1. Is she right? Yep. But what could we call that? We could just call it y, couldn't we? Sine of theta is just y. Where cosine of theta, Skylar, is going to be what? Way over here. X over 1 does make x, she's right. Gavin, what about tangent?
Y over X.
Y over x, good, good. And there's nothing I can do there, I'll just leave that, right? Okay, so why did I make you do it all over again? Because I changed the radius to 1 because it's called the unit circle. Now watch this. Do you guys remember this point on the circle? It's what? It's xy. You know what? I don't have to say it's xy anymore. You know what I can say it is? It's what?
Cosine of theta.
Cosine of theta for x. How come you're saying that?
Is that x equals cosine?
Yeah, right here. X is really just what? Cosine of theta. And then comma, what?
Sine.
Sine of theta. Everybody agree? I don't have to say x comma y. I can say right now, if I want that point on the circle, it's just cosine of theta. If I want, and then the y value is sine of theta. Which leads you to believe that could be written as how? How could you write tangent of theta? Say again.
Cosine over sine.
He says cosine over sine. Is he right?
I mean, sine over cosine.
Sine over, okay. So Harry says sine of theta because y is sine, x is cosine. So yes, you're right, Harry. Tangent of theta is really just sine of theta over cosine of theta, right? Okay, this is one of your identities, and we said we're going to skip identities in chapter 4. We'll come back to this in chapter 5. So in 5, we'll hit that again, and you already know why it is the way it is. Okay? All right. Hey, this next slide is nothing other than this. Just listen. Your book talks about this letter T. But letter T, it represents the corresponding distance on the circle, usually measured in radians. Watch this. See this? That's supposed to be what letter? T. Well, what it happens to be is, it's back here, guys. It's really just how many radians did you wrap around your circle. So I want you to know this when you look in your book today. When you see the letter T, they just mean what? How many radians did you wrap around your circle? Okay? So, T is radians. That's all it is. Okay? Or theta, measured in radians. Okay? There was nothing to that other than to let you know that. Your book went off and started talking about radians in the variable T. Okay? All right, here's what I want. I want domain, range, and period of what? Of this. This function, f of theta equals sine of theta. Okay? Now, what's the domain of sine? What's the range of sine? What's the period of sine? I'm going to draw this circle for you one more time. Here's your circle. Okay, how many radians have I traveled right now? 0. I have not traveled. Okay, but when I get up to here, how far have I went? Pi over 2. Half of pi. Well, pi is way over here, right? Okay, what's this? That's pi. What's this? 3 pi over 2. Okay, and you finally make it back here. It's what? 2 pi. So 0 radians is really 2 pi radians, right? Stuff we already know. Okay, here's my question. What's the domain? Domain is what goes what? What goes in? What can I put in and actually get an answer? Can you put in 0, sine of 0, and get an answer? Sine of 0 is just the y value. Is there a y value right here, guys? What if I told you the radius is 1? Think of the unit circle. Is there an answer? If I say sine of 0, what's the y value right here? 0. There is an answer. How about here at 90 degrees? What's the y value? Up 1, that'd be 0, 1. What's the answer? What's the y value? 1. Are you guys... Remember, we said sine of theta is y. So when I say what's the answer, you're looking and you're going, hey, it's just the y value. It's 1. Okay, what about this one? What's the y value here? Whoops, I wrote that wrong, didn't I? That's going to be what? Negative 1, 0. What's the y value at pi? 0. So my question is, what goes in and actually gets an answer? I know 0 worked, I know pi worked, pi over 2 and pi worked. What? Yeah, doesn't everything have a y value? I mean, there's a point here, there's a point here. Everything gets a y value, okay? So we would say all real numbers work. Here comes the harder one. The harder one would be range, and that's what comes out. That's your answer. Now remember, sine is just y. Y ranges between what and what? This is a hard one. Think about it. Why, Cece? Okay. Here's what she's saying. From here, this is the highest you ever go with y. It's 1. And this is the lowest you ever go. And your y value here is negative 1. So y ranges between 1 and negative 1. It just keeps going back and forth. So your y values would be as low as negative 1, as high as positive 1. Okay, what about the period of sine? Now sine, the period means when does it start to repeat itself? At 2 pi, how come? Yeah, I mean, if you go around the circle, guys, your y value keeps changing, but once you go past 2 pi, you're right back to where you were at this angle right here, or this angle. So 2 pi ends up being your period for sine. Now, I got to tell you this, cosine is exactly the same thing. I'm not going to go through the whole thing again, but cosine is exactly the same. All right? So I wanted you to know what works. What can I put in? Anything. What comes out? From 1 to -1 comes out. And then here, what's the period? Well, once we make a complete circle, we're right back to the beginning again, so 2 pi is your period. Okay? All right. It says here we will find some exact values. Again, this means what to you? No calculator. That's all I really want you to know. Today you will find exact values of all these angles. Okay? All right? And you have to know where you fall in the circle. And I sure hope you're not staring at this over and over, or else this is going to take you way too long. Okay? Reference angles. What are they? I'm going to show you one of them, and then you tell me the other. Ready? If I say 30 degrees, here's 30 degrees right there, right here. Where's the triangle? How do I create a triangle? I don't see a triangle.
Draw a line perpendicular to the
Draw a line perpendicular to the x-axis from the terminal side, and I think that's what you meant.
Yeah.
Okay, and I think you got it right there. That's it. Wow. That's all it is. But the question becomes, what's the reference angle? Oh, by the way, the reference angle, we always say alpha. Alpha is the reference. Okay, what is it? 30. This is an easy one. It's just 30 degrees. That is your reference angle. But what if I ask you this? Draw me a 150. Well, 150 is right there. There's 150. Okay? Again, no right triangle visible until you do what Cece said. Draw it straight down from the terminal side to the x-axis, perpendicular, and back to the origin. Where's the reference angle now? What does that mean? You pointed at it. What does it mean?
Like the left side.
The left side over here?
Yep.
Where? Here?
Yeah, up there down to the 180.
Up?
The other.
This one?
Yeah.
Yeah, this one.
Yes.
Okay. He says this is the reference. Is he right?
Yes.
And what is that? 30 degrees. Now, here's the deal. I cannot tell you how many times students get this wrong. Here's what they do. They draw the 150, and here's what they do wrong. They get here, and you know where they go? They go to the y-axis. They do this, then they come down here, and they call this the reference angle, and that's what's wrong. You can't do that. You have to do what Cece said to do, and that is, once you get to the terminal side, go straight down to the x-axis, back to the origin. There's your triangle. And now, in your words, maybe a little bit of my words, but in your words, what is a reference angle? Where do we find it? Say that again.
The angle closest to the x.
The angle closest to the x-axis.
Closest to the origin.
Closest to the origin. Okay. Good. Good. I like both of them. But can I ask you this? Can I just say this to you? You will always find the reference angle between what? Where is it between? Give me the two lines it falls between. This line?
Terminal and initial.
Terminal and what?
Initial.
X-axis.
And x-axis. Yep. There you go. This is where you find it, guys. It's between the terminal side and the x-axis. Right there. See, you said closest to the origin. That kind of works too. Okay? All right. Good? Okay. That's a reference angle. You need to know what they are. All right. Here's a quick circle. This is kind of like in the beginning of your notes. I had one of these. Here are your radians. Please know them. Okay. Here's the unit circle again. Now the unit circle, again, has a radius of 1. Okay, so from here to here is how far? 1 unit, which means your ordered pair here is 1, 0. I'm rewriting these because they're so small. This one is what? 0, 1. I would recommend you rewrite them because they're so tiny. This one is -1, 0. And the farthest down is what? 0, -1. Okay. Okay, that's all fine and dandy, but what is this? What does it mean to say quadrantals? Okay, quadrantal is what? A quarter of a circle. So that would mean quadrantals are 0 radians, comma, where's the next one? If this is 0 radians, where's the next one? Pi over 2. Next. Pi. Then. Okay. Then 2 pi. Okay. There you go. These are your quadrantals. If you ever land on the xy axis, these are quadrantals. Always use the unit circle. It is so easy. I'll show you in just a second. Just so you know, the other ones that will land on the circle are in degrees. 0 degrees, 90, 180, 270, and 360. Okay? All right. So if I ask you this question, what is sine of pi over 2? Write that down. What is sine of pi over 2? Now I know you're probably thinking opposite over hypotenuse, or maybe you're thinking like this, y over r, okay? But there's no triangle visible, and you can't really make a triangle with any of these. So since sine is just y over r, where do you get your y and where do you get your r?
From the point you get the y.
From the point you get the y, exactly. So you go to your point, here's your y. And your radius is always what in the unit circle? 1, 1, 1. So it's 1. Answer is what? 1. You okay with that? Last hour, somebody kept going, where are you getting these numbers? That y came from the point. That r is the radius of the circle. Okay, do this. Cosine of pi equals what? Hold your answer. Just think about it and hold it for 10 seconds. Okay, Eddie, tell me how to get the answer. Don't say the answer, just tell me how to get it.
You go to the where pi is. So
Okay, right here.
And then you take the x of that.
Say that again. Take what?
The x, so -1
Okay, so take the x value
over y.
over
Or r.
r, okay? And the x value is what?
-1,
There's x, yep, -1.
which is over r, so 1.
Okay, over r, the radius in your circle is 1. So your answer is?
-1.
-1. You okay? Pretty easy, isn't it? So if you land on the xy axis, always use the unit circle, okay? Here's a quick one. Would you please do this one? And that is, let's go with tangent of 3 pi over 2 equals 3 pi over 2. What's tangent? Help me, Aaron. Help me. How do I do it?
Well, we know that tangent is x.
Okay.
So from there you would go with, it's going to be 3 pi when it's back on the left side where it'd be negative 1, 0.
Okay, 3 pi over 2 is, you gotta think of it as 3 divided by 2 is 1 1/2
It's gonna be on the bottom.
pi. Yeah, you're looking right here, guys. Isn't this 3 1/2 pi? Okay, so what am I gonna put in for y over x?
It's gonna be 0 over negative
He wants,
1. Negative 1 over 0.
he wants negative 1 over 0. You guys agree?
Yeah.
Here is y, here is x. So in this one, you steal the y and the x, put them in, and the answer is undefined. It is undefined. So there are times when you don't get answers. This is one of them, right there. Okay? All right. That's good now. Okay. Here we go. Now we're actually going to do some work. This is the work I need you to do on the test. What is sine of 120? Okay, so how do we do this kind of stuff without our calculators? First, you sketch the graph. Go ahead and sketch it. To determine which quadrant the terminal side lies in, are you in quadrant 1, comma 2, comma 3, 4, whatever. Okay. So 120 falls in what quadrant? You're in 2. Okay. So you do know this is 120, I hope. Hopefully that's an easy one for you. Okay. Now step 2 says find the reference angle. What is the reference? 60 degrees right there. Good. So I did this. Complete a right triangle with the nearest x-axis. Oh, that'd be right here. Right there. There's your right triangle right there. Okay. Determine the value, its function value. Well, before you determine it, watch this. Come back here. I know I talked about the unit circle today, guys. I don't really want you to use unit circle. I just wanted to prove to you that sine of theta is y and cosine is x. That's what I wanted to prove to you. Now that you kind of believe me, these are the two triangles I want you to work with, okay? So there's your 30, 60, there's your 45, 45. So what are your legs in this? Opposite of, there's your 30. Opposite 30 is what? 1. Opposite of 60 is what? Square root of 3. And your hypotenuse is always what? 2. Now here's the deal. I gotta let you know this. This is why students get it wrong, because they forget their legs can be negative. Are there any legs up here that are negative? Which one? 1. Why is 1 negative? You went left to get that over there. So that's left 1, up, square root of 3. This is positive. We want sine of 120. Sine is what over what? Don't use words. Use your y's, x's, and r's. Y's, x's, and r's. Y over r, yes. Okay, you got to think. Hey, from here on out, you got to think like this. Opposite over hypotenuse is y over r. So what's y and what's r? Y is what? Square root of 3. Okay, and r is what? Whoa, I did that wrong. Sorry, r is what? 2. Good. All right, this is step 3 now. Based on the sign of x and y in that quadrant, determine whether it's positive or negative. Well, you have what? They're both positive, so this is what? Positive. Sine is positive in that quadrant. How come? Why is sine positive in that quadrant? Well, both y's? Well, the y, all you had to say was the y value is positive. So here's the deal. Sine is positive in this quadrant. Where else is sine positive? Yes, because in quadrant 1, guess what? Sine is up. It's up, so it's positive. Okay? We're going to talk more about that later. Okay? Tangent at negative 225, go. Do it. Take that in. Who knows the reference? Yeah, you went 45 past 180, guys. So your reference is 45 degrees, which means your legs are what? 1, 1, square root of 2. Which leg is negative? Horizontal or vertical? Horizontal is negative. Vertical is positive. You want tangent? Tangent's simply going to be what over what? Y over x, okay? Which is what over what? 1 over negative 1, which makes what for an answer? Negative 1. All done. That's it. By the way, these were degrees, so these are easier for you. So what gets harder for you? Radians. Do it again. Tangent of pi, sine of 7/6 pi, and cosecant of 120. This is a big, big part of your quiz test, okay? Big part. By the way, no calculator. If you're punching a calculator, you are absolutely cheating.
What does that say? Tangent of pi?
Yeah, it does. You can't read it, can you?
Nope.
I'm sorry. Tangent of pi. How about I do this? Tangent of pi. You landed where? Where did it land? On the x-axis. This is the one I said, always go with the unit circle. If you land on the x-axis, the radius is always 1. What's this point right here? Negative 1, 0. You know tangent is what over what? Y over x. Well, this is x, and this one's y, so what's it going to be?
0.
0 over what? Negative 1, which makes?
0.
The answer is 0. Tangent of pi is 0. Now, if you land on x or y, use the unit circle. But if you land somewhere else, use your special triangles right here. Here, here. Okay. Get the next one. Your eyes actually look closed from the last thing. So period 6 and 5, or sorry, and 4, you guys are period 6. So period 5 and 4 struggled with this. They said, where do I go for this? Well, if you can't do this in your head, you are going to have to convert it to what? Degrees. You're going to have to do this kind of work on your quiz, which is too bad for you because this takes time. Okay, ready? Cross out the pies. 6 goes into 6 once, 6 goes in here 30 times, and 7 times 30 is 210. Did you know you're at 210? Okay. But, please tell me, you can do this without converting. Can you guys do it without converting?
Yes.
Tell me this. 7 over 6 is really what number? A mixed number. It's 1n, 1/6 pi. Guys, 1 pi is how far? Yeah, it's right here. That's 1 pi. How much more do you have to go? 1/6 pi. What's 1/6 pi? 30 degrees. So you should know you only have to go how much more? 30 more. There it is. What's your reference angle? Right here. 30 degrees. You went 30 past 180. That means this side is 1, this side is square root of 3, this side is 2. Which legs are negative? They both are, aren't they? That's negative because you're going backwards. That's negative because you're going down. And what is sine? What over what? Y over r. So you're going to get what? Negative 1 is y over r is what?
1,
2. Answer's negative 1/2. It was a nice, easy answer. It's just sometimes you just can't get that angle correct. All right, this one's not hard. It's just that it's what? It's cosecant, right? I don't think it's going to be hard for you, but just be careful. All right. So 120 would be here with a reference angle of what? What is it?
60.
60, good. That means this is the square root of 3. This would be what? 1. This would be 2. Which leg is negative? 1. You had cosecant, correct? All right. So
Opposite of sine.
it's the reciprocal sign. So if it's the reciprocal sign,
R over y.
r over y. Can you guys do that in your head? Instead of thinking of sine and then writing it down and then flipping it later, I just do this. This is what cosecant is. What is it? R is what? 2. Y is what? No, y is square root of 3, isn't it? Right? Okay. And multiply by square root of 3, you get what? 2 square root of 3 over 3. That's it. Did you get it? Okay. All right. Even and odd. You ready? Even means what? Back from chapter 1. Even is what? Symmetrical to what? Ooh, somebody said it.
Y.
Y-axis. There you go. Might want to write that down. I don't think most of you remember that. Okay. How about odd? Odd means what? Symmetrical to? No. That was a good guess. It was a good guess. Symmetrical to the origin. Okay. Even is the y-axis. Odd is the origin. How do we check for this? Well, it says right here what to do. Take your x and do what? Make it negative. So basically switch what? Switch your x value to what? Negative x. And if you get the same as f of x, then it is even. Okay? Now what do you do for odd? Odd, you have to switch what? Switch, whoa, what did I do here? I switched what? I didn't switch x. I switched what? F of x is y, correct? I switched the y, didn't I? Switch y to negative f of x and switch your x. So if you switch them both, guys, then if it works, if they're equal to each other, then it's odd. Yes? You remember doing this?
Yeah, but I don't know why we did it.
Well, just to help us know if something is symmetrical. If something is symmetrical on this side, then all I gotta do is mirror it over here. If something's symmetrical to the origin, if I get something up here, I know it's down here. I don't have to graph. I don't have to make points. Symmetrical helps because I do less work. That's all it does. Okay? So let's do it. Ready? All right. I'm going to check for sine. Is sine is an odd function or sine is an even function? What am I doing here, guys? See this? Sine is 30. And then I did sine of negative 30. What did I switch?
X.
I switched the x. If the x is 30, and then I make a negative 30, all I've done is what? I switched x. That's all I did. Now, what is sine of 30? You guys know? Look, it's right here. Sine of 30. Okay? 30's here. What's this side? What's the hypotenuse? Square root of 3. Tell me the sine of 30. 1/2. Okay. Does that equal? What if I switch it and make sine of negative 30? Well, that's down here, isn't it? Okay, the drip can stop. Okay. Sorry, didn't match up very well. Okay, this is square root of 3 still, right? What's this side? Negative 1. And the hypotenuse is 2, isn't it? So what's sine of negative 30? Negative 1/2. Is it even? Or I checked for even, didn't I? That's even when you just switch x. Is it even? No. Don't write even. Is it odd? No? You don't know. You haven't checked. You should check. How do you check for odd? Let me show you quick on a different slide. Here's odd. Odd is this. This is odd. Switch x to negative x. Switch y to what? Negative y, correct? Okay? All right, well, here we go. Sine of 30. That's x, but I'm going to put what out here? A negative. I'll put it on front. Equals, now I'll do what? Sine of negative 30. Okay, ready? What is sine of negative 30? We already did it on the previous slide. Negative 1/2. Good. What is sine of 30? Half. Doesn't look good until I do this. That goes out in front now. You know what I was doing there? I was checking to see if it was odd. Right? Odd is when you switch them both. Odd, switch both of them. So did it work? Yes, it worked. It's odd. And what does odd even tell you? Symmetrical to what? Odd starts with O. Origin starts with O. Origin. What about cosine of 30 and cosine of negative 30? You can get those answers quick. Finish it. Basically, I just switched x here, didn't I? Switched x. That's what I did. So that means I'm checking for which one? Even. What's cosine of 30? Square root of 3 over 2. Got it. What's cosine of negative 30? Square root of 3 over 2, yep. Oh, look. They're equal. Is it even? No, it's even. Even means it's symmetrical to the y-axis. That's all it means.
Is there a possibility of being odd and even?
Yes, there are possibilities. I don't know if it happens with the trig function. I'd have to look at it. I can't remember. Okay? Do tangent. Right now. Everybody do tangent. You should know how to do it. Tell me what you think it is. I'll come by you and I'll just say yes or no. So, anybody got it? What's tangent? Even or odd? And hey guys, do 30 and negative 30. Don't go to different angles. Okay? If all I do is take the original tangent of 30, but I just switched 30 to negative 30, that means I switched what? I was switching what? X. So that means I'm checking for what? Even. Okay, what is tangent of 30? Maybe a couple visuals. There it is. Say again. Okay. Okay, you must have rationalized. Can I do this? Opposite over adjacent. 1 over the square root of 3. Okay, what's the other one? Negative 30. Negative 1 over square root of 3, isn't that the same? No, is it even? No. But is it odd? Here's the deal with odd. Just put the negative in front of your function. Well, the answer to tangent of 30 is that. That makes it what? Negative. They're equal now. It's what? Tangent is what? Odd. And odd just means it's symmetrical to what? The origin. Okay, we made it. I'm going to say this one more time. The unit circle is really used only for what?
On the axis.
Quadrantals. When it lands on the x-axis or the y-axis. Otherwise, guys, would you please go with the triangles you know very well? Okay? Now, the little snowstorm you guys had yesterday, yeah, it was all fun and, awesome, and we all loved it, right?
No.
Did you happen to look at your calendar now?
No. Yeah, you
What does it
predicted
look
it.
like? When are we quizzing?
Today.
Yeah. That snowstorm pushed your quiz to a Monday. I'm sorry.
Good.
You were loving it yesterday, but you're not gonna love it next Monday when you have to quiz on Monday. I'm sorry. Maybe there'll be another snow day on Monday. Then you'll get a Tuesday.
Then we have one time. Yeah.
You know what?
We have a 2-day weekend, a 3-day weekend.
One time it's done.
By my house, they were taking
I don't know.
I don't know if
When I charge my phone on
she technically is on the wall, so when she's sliding down.
And then how fast do you do it? Oh, you're done. You covered how much distance? 25 radians.
Killing me. Killing me.
How fast do you travel? Which is always far away.
Until she grew up.
You covered per minute.
really just find someone else. And also don't eat ones on anything.
Yeah, but what's the minimum?
10,000.
95 feet per.
Alexis Rail, would you please report to the main office? Alexa Rail to the main office. Thank you.
I want miles instead of feet.
So
Miles.
over. So what's a half? What's a mile?
5,280 feet.
5,280 feet.
And
That's
then
like the only conversion I even know off the top of my head.
and then for minutes it'd be you'd put minutes on.
For meters, it's
Blanca Gomez, please come to the main office. Blanca Gomez, please come to the main office.
1 hour. So that's gone. That's gone. And you get whatever miles per hour.
Divided by.
Mr. Payne.
Yeah.
I'm not sure if it's next week, next Monday, or the Monday after that. I had to take my cat for a routine checkup to make sure the worm communication is working.
What day? What day?
Next Monday or the Monday after.
Next Monday or the Monday after. Okay. Okay. Well, guess what, John? You just tell me when that comes. I don't
All right.
keep track of that stuff, but